Hello guys, so let's solve today's Leetcode challenge. Problem number 2579, count total number of colored cells. So there exists an infinitely large two-dimensional grid of uncolored unit cells. You're given a positive integer n, indicating that you must do the following routine for n minutes. At first minute, color any arbitrary unit cell blue. Every minute thereafter, color blue every uncolored cell that touches the blue cell. So here is the pictorial representation. So this would be at t equals to 1. The first cell. This would be t equals to 2. I have covered the surrounding 4 cells with blue color. And this would be t equals to 3. These surrounding cells are also covered by blue cells. So let's build the logic up using the examples. First example is n equals to 1. So this is at t equals to 1. We can only cover one block, so our answer would be 1. Now for n equals to 2, we have 2 seconds. So at first minute, this one block would be covered. And on the second minute, the surrounding 4 cells are covered. So we get this 1 plus 4 is 5. So our output is 5. Now for n equals to 3, this is the pre-existing block of cells. These 5. I would cover the surrounding cells with blue color too now. This one was not the previous color. So I would, okay, I would erase this one. So here we are getting 1 plus 4 from the previous. Um, these cells were already color blue from the previous iteration. And this from the new one, the third second, which is 1, 2, 3, 4, 5, 6, 7, 8. 8 cells. 13 is the output. For n equals to 4, again I have all these 13 cells present already. I'm just covering the exterior ones with the colored ones from uncolored to color. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 extra cells for t equals to 4, which is what I'm adding in the output, and I'm getting 25. So I will only convert this into a formula which I'm doing. For t equals to 4, I have this already pre-existed, and this I can calculate as 12 equals to 4 into t minus 1. The formula. T is 4 here, so 4 into 3 I would get 12. Same goes to n equals to 3. This was already present. I had to add 8 more cells. So 8 can be calculated as 4 into 2, which is anything but t equals to 3 here. So 3 minus 2, we are 3 minus 1, we are getting 2. And this is equal to 8. 8 plus 4 plus 1 is 13. Same is for n equals to 2. 4 into t minus 1, we get 4. This is our initial given in the question. Like for 1, I have the output as 1. Because 4 into t minus 1 would be 0. So we only have 1. So we will initialize cells with 1 and increment cells with these 4 into t minus 1 values every time our t increases. That would be our basic simulation approach code. See, I'm initializing t with 1, cells with 1, while my t is less than equal to n. N is the number for which we have to calculate how many uncolored blocks have turned into covered. I would add the 4 into t minus 1 because that is the amount of cells which will get converted every t seconds. So this is it, and I would increment t here. T plus equals to 1, and later on I would return the cells if t ever becomes greater than n. So I would just return the cells as our answer. Time complexity would be O of n here, and space complexity would be O of 1. This is our simulation to code. Now let's go on to the second approach. We can even better the time complexity from O of n to O of 1. In this case, we have the constraint as n value ranges up to 10 power 5, 1 to 10 power 5. So this solution will also work, but let's see an optimization using maths as our second approach. So let's suppose we are given n as 4, n equals to 4 here. So for t equals to 1, we know that we would have one colored cell. For t equals to 2 also, we know we have 4 into t minus 1. For t equals to 3, we know 4 into t minus 2. And we were summing up this, we were initializing cells with 1, and then we were adding up all these values to get our final result. So let's see if we can do a mathematical formula optimization from here. Number of terms is n. So by taking 4 common, we can see that this comes out to be sum of n minus 1 natural numbers, because n is 4 here and we have 1 plus 2 plus 3. So we would put it in the formula of n plus 1 by 2, which is the sum of n natural numbers. Instead of n, we would write n minus 1. So we would get this. This would cut off to 2. And the final result we get is this. 1 plus 2 into n minus 1 into n. So we would just return this formula. For every n value, we would get the corresponding number of colored cells after that many minutes. N equals to 4. I'm adding n as 4, n minus 1, 3. 2 into 3, 6 into 4 is 24 plus 1 is 25. Time complexity here is constant time because we are just using a formula, and space complexity is also 1 since we are not using any extra space. So these were the two approaches. Now let's code them. So let's code the first approach. Here I'm initializing t by 1 and cells by 1, while my t is less than or equals to n. I would just increment cells by 4 into t minus 1, and I would also increment my t value by 1. Afterwards, if I break out of the loop, that means t is greater than n. So I would return the number of cells I get. That would be the colored cells value. Yep, it's passing the given test cases. Hopefully it passes all the test cases. Yep, it is. So now let's code up the second mathematical code. This is also very easy. I would just return 1 plus 2 into n minus 1 into, okay, wait, 2 into n minus 1 into n. I have derived this in my dry run previously. You can check it out, like shifting the timestamps accordingly. It's passing the given test cases, and it's also passing the hidden test cases. So today's Leetcode challenge is done. Let's meet tomorrow. Bye bye.